Welcome to our lesson where we will explain the server-client configuration on Wise SCADA. I prepared a project beforehand. I created the tags and designed a page. I prepared the same for the client as well. We are adding a server here quickly. First, let's explain this. There are many protocols available in Wise SCADA that can work as a server. One of my favorites among them is Modbus. When we select Modbus, we add SCADA's tags in the tags section and write the Modbus addresses corresponding to them. Now, if we configure this SCADA in this way, SCADA will be ready to work as a Modbus slave. Your other automation devices or SCADA programs can connect to this SCADA with Modbus master code and query these addresses. Thus, they can read the values of the tags or write set values. In short, this SCADA will have created a Modbus bridge with its own tags. Other protocols allow your web pages or other applications to receive data from or write data to SCADA. We will use the Wise SCADA protocol in our lesson today. We will make two SCADA stations communicate with each other as server-client. In the Allow All IPs column, we have currently enabled all IP addresses that want to connect to this SCADA. When we uncheck it, we have to enter the IP address. For example, I defined an IP by writing 192.168.0.10, and I am adding 11 as well. Any device other than these two IP addresses cannot connect to this server. Let's check the All IPs option again. We determined our IP address and we must select a port number. The client will connect to us with this port number we selected. There should not be another application using this port on this computer. Otherwise, whichever of the two opened first takes that port. We can also define UDP at the same time. This server responds to calls coming from both UDP and TCP. When we check the write access tick, the client connected to us can change our tag values, that is, write set values. In this configuration where all tags is selected, all tags in this SCADA project can be read by clients. Since write access is open, it means they can be written as well. Or we can open this to specific tags. If we don't want all tags, we limit reading and writing by clients to only these selected tags by making a tag selection. The first column here is the name of the tag in hours, and the second column is the name by which the client will ask us. We can change these names. For example, if we make the tag name tag 2, when the client asks for tag 2, we will give the value of tag. In the type section, the data type in both SCADAs must be exactly the same. Now let's delete these and let it remain as all tags. We activate the server with the Activate button. If there was a client wanting to connect to us, we would see the communication data in the table below. There is no such client for now. I defined 3 labels before, I am selecting them here. Listening tag will be true when the server is started successfully without any problems. If the server cannot be started due to a problem, the fault bit will be true. Responded is a tag of string type and we can use it for operators to track the connecting IP address. We finished our configuration on the server. Now we come to the client. I am adding one client. Wise SCADA protocol is selected. The IP address to connect to is 127.0.0.1. Since we are working locally, the port number is 8000. We configured its type as TCP. We continue from there. If we select Get in the Methods section, we can only read data from the server. If we select the Set method, we only send set values to the server and never perform reading. If we select the Dynamic method, we read data from the server. And when the operator changes the values in this SCADA project, we go and write to the server. In the Tag Lists section, there is no All Tags option like in the server. We have to select tags one by one here. The structure is similar again. We must write the name of the tag in this SCADA in the first column, and the name of the tag in the server in the other column. If the tag name is different in the server, we must change it here too. The tag's type must definitely be the same. Different from the server, there is the Enable feature in the client. Operators can stop and start the operation of the client in Runtime. We requested the client to work if the value of a Boolean type tag named Enable is true. Communication can be done with two different methods or both at the same time. If we select the Trigger method, for example, when the tag value is 1, we will receive information from the server once whenever the trigger condition is positive. If we select Period, currently 1000 milliseconds is selected, we will update the values of all these tags we selected from the server once a second. We can use these two together or separately. If we want to receive data very rarely, we can select Trigger, but if we are going to receive data continuously, it would be more logical to select Period. We can determine the connection timeout duration and the retry count from here. If we are establishing communication remotely over the internet, we can enter this time longer. Here there is connected, the other one had listening. We have two variables of Boolean type for connected and fault. We also have a variable showing the connecting IP address. It shows connected when the connection is successful, fault when there is an error, and which IP address we connected to in a successful connection. Why do I say which IP? Because there can be multiple IPs. We define two here. If it fails to connect with the first one, it will try with the second one. In which situation is this used? In a situation where we connect to a server via different paths with different Ethernet adapters, or if there are two different servers. There can be a redundant configuration where we can receive data from whichever one we can connect to. Now I am pressing Activate. The red color shows that we could not connect. I am pressing Activate on the server as well. We immediately saw that the connection was established on the server. The description of queries for communication and received answers are also present here. I am closing these and starting the runtime now. I started the runtime on the client side. I made the server deactive and started the runtime there too. Now I have two runtime projects, let me move them to the middle of the screen like this. Listening became true on the server side. Communication was started without any problems and you see the connected IP address here. Even if I delete it from here, since the client will connect again, this IP address will be written there automatically again. Enable is done on the client side and it is connected to the server. There are no errors. We can also see the IP address of the connected server. When a value changes in the server, we see this in the client part, and when it changes in the client, we see it instantly in the server part. When we remove Enable, make it false, even if we change the value, we won't be able to see it because the communication is cut. When we turn on Enable, we will quickly receive the value in the server. This configuration is used for multiple SCADA stations to share specific data with each other. There are no restrictions. Hundreds of SCADA stations can communicate with hundreds of clients. A SCADA station can work as both server and client at the same time, thus we reach an incredible network structure. Now, its other working mode is different from the server-client configuration. Let's close the client project now. In this configuration mode, this project will still work as a server. We need to configure the exact identical copy of this to work on another computer. When we configure it this way, there is no need to select tags one by one as we did in the client. We will do it much faster and easier. First, I am saving a backup of this project. I named this my server. I saved it and currently the my server project is open on my screen. I am completely deleting its server configuration. I come to the setup section, select the client option, and say you will connect to the server at this address and get its data. The configuration required to work as a client is finished, that's it. There are tags here but these will never communicate with PLCs. The values of these tags will be retrieved via the server. When used in this way, we have a very affordable client license model. It is enough to buy that license. That is, you can run the exact copy of the project you run as a server on one computer, on other computers very quickly. Now I am running this my server project. Remember we had changed its name to my server just now. I am running this in Runtime, let it run there. I open the project we call my server, that is, the one we moved to the other computer. We said connect, connected, verified. There are no errors. Finally, let's change its name here. We need to call this client now. And let's run Runtime on this one too. Let's open the other one too. Yes, windows overlapped. Let's change a tag's value again, and see the other one changing on the other side. As you can see, we now have a second SCADA station working on the other side, on the other computer. And we achieved this by writing almost no code, just by saying you are client in the setup section and showing the IP address. You can run your project on many computers at once. Thank you for watching our video.